Yeah, this is Dr. Hertz's wife made this picture right in the bug. So how I learned to stop worrying and love the bug. Debugging is just a part of programming. Learn to love it is the best advice. When I write code, I just expect that it will be buggy, and then it's an adventure to find those bugs and squash them. It can be a fun part of the job depending on your perspective. If you're not expecting the bugs, then I actually don't know the reference. It might be a Kubrick movie then. I don't know the full reference. But if you enjoy the hunting of the bugs, and or at the very least, expecting it, because there will be bugs. It's just part of programming. If you can program perfectly with no bugs, more power to you. That's fantastic. But you should just expect bugs. You're going to have to find and exterminate bugs. It's part of the job. So just a few quick reminders before we get into... It's Dr. Strangelove. I'll have to look into the reference sometime. Oh, that's I see. So that's supposed to be a bomb, and then... Yeah, I get it. So just a few reminders and kind of clarifications about project management. There's been some confusion, and Dr. Hertz and I have been talking, making sure that we can get as much out there, reduce the confusion as much as possible, I guess. I'm confused on how to sputter out this sentence. Anyway, let me just go through my slide. So your project manager is in charge of your project. This is something that caught a few of you off guards. They are a project manager. They are your manager. So they're going to make a lot of decisions about your project and kind of take ownership of it, and you're working for your manager. So we are taking the title of project manager seriously. They are the manager of your project. So one example of where this comes into play this week, if you've had your meetings this week, you've known about this. If you haven't had your meeting yet this week, this is what you can expect to see. Is you'll write the user stories. We obviously did this last Friday. You write your user stories, but your project manager is going to choose which stories you complete each sprint. You will obviously have input here. Work with your project manager, just like in the real world. We're trying to simulate real world as much as possible. Work with your project manager. You can make arguments for which stories should be completed on which sprints, but they ultimately get to decide which of your stories you're going to complete each sprint. They're also, especially this week, they're going to help you refine your stories. If you have some really poorly written or weak user stories, they're going to help you get better user stories, so it's very clear what you're working on throughout sprint 1 at this time. Your PM is also going to decide which tasks are assigned to whom. Most PMs, I believe most, are going to assign only one team member per story. So if you have very large stories, and one of your stories is, for example, captures the essence of build the GUI, they're going to want you to break that down into smaller stories, and I recommend breaking that down into smaller stories, which you definitely should be. Break it into as small as you can, but still capture a full feature. So maybe there's a specific button on your GUI that should do a specific thing. Maybe that's one story. So break those down. Break those down for you. Do PMs grade us? Not directly, not officially. The PMs will submit to me reports, and then I get the final say in your grade. So if you have a PM who's just a really harsh grader, I'm going to a harsh assessor. They're going to fill out the rubrics, by the way. If somebody's really harsh and I look through your code and I'm like, well, this looks pretty good to me, I can up your grade. At the same time, if your PM is very generous, I'm going to lower whatever their recommendation is. But I am grading you. Your PMs are giving recommendations to me. But your PM is going to decide which tasks. Most of them are going to assign one student per story. So if you have a group of 5, you should be working on 5 different stories at least. You might have multiple stories per team member. At least 5 stories for sprint 1. And then your PM is going to also decide which tasks you work on each week. So you'll get a story. this week, this story, this is the one you're working on for this sprint. And then that can be broken into tasks. You will break that into tasks, and your PM will decide each week what tasks. You're going to work on this task, and next week you're going to come to me with this task complete, and then you're going to get another task. So that's roughly the workflow. But the PMs do have a lot of flexibility in exactly how they manage your project. Each project manager is going to have their own style, just like in the real world, and each project itself is going to require a different approach. Each project is going to just naturally have different needs and needs for that project. Maybe your project just naturally is a small handful of very large stories that just can't really be broken down. Maybe they're very small features to the user, very simple use cases, but maybe you have to build a huge backend and huge data analysis portions just to get that one small feature working on the front end. In those cases, you might have multiple teammates per story, but that's up to the PM to decide for your specific situation and for their particular style of management. We expect this. We embrace this. It's part of embracing change. It's part of being an agile team that you should be expecting your PM to make decisions that are going to be different than other students in the class. We should expect this. We should embrace this. Shouldn't teammates decide what tasks? So you're going to have a lot of say in that. You can make arguments that, hey, by the way, your PM is invested in the success of your project. Their goal is to make your project succeed, by the way. They want your project to succeed. So if you say, I don't know anything about front-end web development and we're building a web app, your PM shouldn't be assigning you front-end tasks. You should be able to go to your PM and say, and part of this week's meeting is, your PM should find the strengths of each teammate and assign you tasks associated with your strengths. So if you sat down with your team and said, I'm going to be the database person because I love databases and I used MongoDB before and we want to use that for a project. Somebody else says, I love networking, so I'm going to handle all the network communication. Odds are you're going to say all that to your PM, and they're going to assign you tasks that you would have assigned yourselves naturally. So it's not as scary as it sounds. They're not going to assign you random tasks or things like that. You have a lot of say. But this is where communication comes in. You have to be communicating with your manager. If they don't know that you're expecting to do databases and that's your strength, they don't know to assign you the database task. So if they assign you a task that you're not comfortable with, speak up. At least make your case. You might still get that task assigned to you or that story assigned to you, but at least make your case and communicate to your manager. This is ever crucial out there in the real world. These are skills that you'll have to have if you want to have a nice low-stress career. If you're just taking whatever your manager gives to you out there in the real world, you're going to be miserable. You're going to be stressed out. Never be afraid that in this class or beyond out there in the real world, never be afraid to tell your manager that they've assigned you something that you just can't handle. Hell, I just did this yesterday in a meeting. We were talking about stuff, and the person I was meeting with wanted me to do something. I'm like, sorry, I'm not going to do that. I mean, I can't get into details, but I can, I just wasn't going to do it. I'm already stretched too thin. I'm like, I'm not doing that. Okay, whatever. They're going to have to figure that out. Because ultimately, again, this class and beyond, your manager is responsible for the success of the project. They want the project to succeed, and if you bring up an issue early to them, they should, if they're a good manager, they're going to listen to you, and be happy that you brought that issue up to them early before it became a big issue, because it's easier for them to solve a small issue than it is to solve a big issue. So bring up things as early as you can, and things will be fine. And remain calm. Yeah, don't panic. At least until you meet with your project manager. If you haven't had your meeting yet this week, don't panic about anything I'm saying yet. Just know what to expect. Know that meeting won't go the same way that it would if it was just your team without a manager. And the reason we do this is because, to be frank, y'all are, I don't know about this class specifically, maybe you're an anomaly, but in the past with 442 students, y'all suck at managing yourselves. Like you just can't do a good job. And there's no reasonable expectation that you should be able to do a good job. You've never been in a position where you had to manage a project before. So that's why this change has happened, and I'm happy with the way this course is structured now with project managers. Whoa. Y'all, I mean, with and in 116, I mean, even with prepackaged assignments, they can't even manage their time usually. So you can get mad at this if you want, but it's the projects turn out a lot better than when we have students manage their own teams. Which I've done every other time I had 442. I had students manage their own teams, and by the end of the semester, the projects, even really great students that I know are capable of much better, their projects just aren't there. They just don't. They're just not finished, barely even started in some cases. So anyway, let's move on. By the way, this is a 100% original Jesse Hartloff slide. I mean, I guess I stole the colors, the template and stuff. And I tried making colors like Matt does. So if it looks off, it's because I use my own colors. I didn't tell you to get good. I said you're not good, so we're going to send a project manager to make sure you succeed as much as I know you're capable of. Because right now you're at the point where you're very good at writing code. You're very great developers, but you're not great project managers. And really it is setting you up for failure. If I put you, say, go in groups of 5 with no manager and manage yourselves, you're not ready for that. If I did say this one particular member of your team is your project manager, the projects will end up better, but then there's also can be some resentment within the team. Wow, I'm a great developer. I mean, I assume you're all great developers at this point. But you shouldn't be expected to manage an open-ended project like this on your own, because how do you do that? Who takes the manager role in a group of 5? And if nobody steps up, and you can just go directionless. It's a very hard thing to do, even for experienced developers out there in the industry. It's hard to manage yourselves. This is just a tough thing. So I used to expect 442 students to manage themselves, and I realized that's just beyond, not beyond what you're capable of, but it's beyond what a single course should expect of you when you're first learning how to work as a team. It's just too much. It's just too much to handle in one semester from one course, especially when you have 3 to 4 other courses pulling you in other directions. Anyway, let's get into this, because I already spent 15 minutes and haven't gone through one slide of this. I don't want to talk about that stuff. Let's talk about, you can read this on your own. You probably have when I had it up. But yeah, there's nothing I need to reemphasize there. I do want to reemphasize the difference between acceptance tests and task tests. So acceptance tests are associated with your user stories, and this is how the end user and all stakeholders of the project can verify that a feature is complete and that it exists. So when you finish a story, a user story, you have your acceptance tests, which is a list of steps that the end user can take to verify that it exists. It's non-technical, and it's meant for those non-technical people to verify. Task tests, on the other hand, after you split a story with acceptance tests into your separate tasks, each task will have a task test, which is the more technical, really detailed developer-facing tests. These are your tests. These are where today we'll talk about this in the context of unit tests. Friday we'll talk about some other different types of tests, some GUI tests that we can do to automate GUI testing, for example. Task tests are when do we know that this particular task has been completed? And these tasks are the technical tasks. The tasks are, set up a database, build these SQL tables, all those really technical, detailed things. So task tests are what we want to talk about today. We already talked about acceptance tests. You've already written a lot of acceptance tests. tests is what we want to focus on today. Some of this will be a little bit review of 116, probably the last time you used testing or wrote any tests. But we'll go a bit more in depth than we do in 116. So, secret to good code. Good code works. But how do we know it works? How do we know code works? How do we avoid these error messages? I want to rip through these, so I won't give you quite enough time to read those. You can check them out on the slides. They're hilarious. So we test to make sure that our code works. So how do we do this? And one solid piece of advice is when you're writing code and when you're designing your code, make sure you design it in a way that can be tested. If you write, for example, when you first start developing and you have a project you want to write and you throw all of the code in one main method, that is not testable code. You can't test that except by running the program and clicking around and using it and seeing if it kind of works the way you want to. And once you start splitting it into separate classes, separate methods, separate functions, whatever, the language or whatever calls for, now you can start testing each piece of functionality independently. You can't really do proper unit testing if your code is in these huge jumbled methods or functions. You can't pick apart each piece of functionality and test them independently. You're going to be testing way too much at once. Beyond reasonable expectation. What is it? Viscale how? Is that how you say that? Yeah, thinking about selling my project later. Most projects suck. So I've seen this way too often. So I kind of go back and forth on whether I allow private repos or not. And in the past, when I have allowed them, I'll have these teams who want private repos because they think they're going to sell their project. They think they're going to write the next greatest thing that's going to go out there and revolutionize the world. And by the end of the semester, it's always some pile of nothing. And it always baffles me how some students' egos are just so inflated that they think they're going to spend 14 weeks and revolutionize the world with this amazing product and get rich. It's absolutely crazy. And then I always like to remind you, and I'll remind you all right now, how much free code you're using. Even the smallest library that you're using, I guess unless you're using JavaScript, that's a side note. But the smallest library you're using to develop your project is probably way more involved and way more in depth than what you're going to write this semester. So that might sound, actually, hearing me say it out loud, that sounds a little depressing, but just think of how many decades people have been working on this stuff. Whatever language you're using, the language itself and the compilers or interpreters and all the standard libraries that come with that language, think of how much work went into that, and you just get to use it for free. And you think you're going to spend 14 weeks and get rich? I mean, if you could, somebody would have already wrote that app. Well, not necessarily. But if you really do pour your heart and soul into something and find a niche market, you absolutely can make some money off your project this semester. But it's just frustrating when I see students with these dollar signs in their eyes. I'm going to get rich, and then they half-ass their project, and of course it's not going to go anywhere. On the other hand, I saw a few projects that could have monetized and could have done really well, but they stopped at the end of the class and then just didn't go to market with it. There were a few apps that I really would have liked to see. I even pushed the teams, tried to get them to sell it and monetize, but they just didn't want to take the time to take the next steps, unfortunately. But you absolutely can build something. I don't mean that to be a downer. But anyway, I'm getting way too sidetracked. Write your tests first before. You could pitch your team's ideas. Send it to me in Slack. You can when you create DMs in Slack, you can add your teammates to it too, if you want to have everybody there, or invite me to a private channel with y'all. However you want to do it. Yeah, you absolutely can. I love to hear project ideas. Which of course I have through the forums, but I always like to hear more. So test-driven development, you may have heard of this before. It's where, to sum it up, you're writing the tests before the code. So you're writing tests for code that does not exist which you might ask, so you might ask, how do I write tests for code that doesn't exist? Well, this is really the fundamental part of test-driven development, is it forces you to think about what your code is supposed to do before you think about how it's going to do that. So if you had to sit down and think about the tests, you have to think about the input-output behavior of these methods and how your code is supposed to behave, which if you don't know that, how the hell are you writing the code? Like, if you don't know enough to write those tests, you don't know enough to write the code because you don't know what you're supposed to be coding. When we write tests, we usually write tests like this. They're going to be giving our code a very soft, gentle touch and not actually testing much. We really should be writing tests that are really going to get in there, tear our code open, get in there, and start looking at all of the small details, make sure everything is rock solid with that code. Our test should find every single bug. And when we write our tests, we're going to assume that the bug is there already and make sure that our test finds it. So every test we write, we have a bug in mind. Every test case, at the very least, we have a bug in mind. And we're going to write a test that is going to find the code. If my code has this particular bug, if I give it the input 0 and it's supposed to return 0 no matter what, I'm going to write a test case for that and make sure that it can find that bug. If I'm sloppy with my code and I don't handle that edge case of 0, then I want a test that's going to find that, that's going to expose that and have big red flags flashing at me and saying, hey, your code is broken, fix this. And if I do TDD, if I write my test first and I make sure I have that case written already, no matter what I write in my code, that test case is not going to pass until I've written code that does not have that particular bug. And ideally, you can cover as many bugs as you can think of with your tests, and then write your code until all those tests pass. I'm ahead of my slides a little bit here, but ahead of Dr. Hertz's slides, I should say. So we're going to write our tests before the code. So when we write our code before the test, when we're writing our tests, write the code just completely stubbed out. If it returns like an int, just have it return 0. If it returns unit or void, depending on your language, if it doesn't return anything, just write the function or method header. Just write the class names and definitions. Don't put any actual code in here because you're not building any functionality yet. But build the method names, the class names, have all the definitions there and the declarations there, so you can write your tests and your tests don't crash. Your test doesn't say that class doesn't exist. Just write stubbed out code. So your class technically exists, the methods technically exist, but they don't do anything. Yeah, there's no such thing as hope, only work. Absolutely. It baffles me the number of students and the amount of times I deal with this where students put almost no effort into something and expect a good grade. No, just put in the work. It's nothing we do is really that hard, even in computer science. It's just time consuming. You got to put in the time. It's an excellent quote. And you got to think about the input-output behavior, like I said. And then after you write your tests, then implement your methods. And if your tests pass, then you're fairly confident that your code that you just wrote works. So how can I write tests before I know what the method does? Of course. How can you write the code before you know what the method does? How the hell are you going to do that? How are you going to write your code when you don't even know what your code is supposed to do? It's just a silly... this is just a really silly complaint. How can you write your test before you know what the method does? The hell are you going to write your method then? So you got to... So TDD kind of forces you to plan ahead, forces you to think about what these methods are going to do. Think about the structure of your code. What classes do I need? What methods do I need? What functionality is going to go in each? And design your code before just diving in and just typing code at random until it kind of resembles something that might be a working project. TDD, think about what the behavior is supposed to be of each piece of your code first, and then go forward. So this can seem strange at first, but if you haven't done it before, but it is well worth, at the very least, trying. Oh, take the time to adjust. But always check the results. You don't care about how. When you're writing these tests, any testing, you never care about the how. You're just caring about what. On this input, did you give me the right answer? Cool. I don't care how you figured it out. So never check like local variables in a unit test, for example. You don't care how things happen, just that it worked. Because you could implement the same method 2 separate times with completely different implementations. They both have the same input-output behavior. Cool. Oh, yeah, you deserve that, Eugene Krabs. She says that at the top of the first lecture of every class, I believe. Probably in all her syllabi as well. I mean, if somebody takes that seriously, make sure you take it seriously too. Just like at the first lecture of every class I teach, I just say, call me Jesse. That's me saying, just call me Jesse or whatever. But if somebody on the first lecture says, you will call me doctor, just call him doctor. Basically, that's in Friday's lecture. We'll talk about a little bit of UI frameworks for testing. The one I'll highlight is Selenium for testing web apps. You can actually write a script. You can pull up your browser, click around, and write a script as you're working with your GUI, and then run that script in an automated fashion so it can test your GUI kind of like a unit test. Yeah, right. Selenium is not unit testing. Like today we're talking about unit testing. Friday, different topic. Not unit testing. So if we create, I already said a lot of this, and I have a lot of slides, so I want to go through them. One advantage of test-driven development, you have your tests written before you're writing your code. If your tests are passing and then you make a change to your code, say you have the method pretty well written, you make a change and now your tests fail, you've narrowed down the bug to that one particular change. You know exactly where to look. As opposed to writing your entire method, then writing your tests, and then running them and having your tests fail, you don't know where your bug is. It can be anywhere. But if you have the tests already and you break your tests, a test that was passing fails now after you wrote one line, guess where your bug is? Very easy to debug. Maybe hard to debug, but very easy to find where the bug is. So most languages have some unit testing library. Depending on when you took 1.16, you either saw JUnit in Java, or if you took the new one, you saw Scala test in Scala. But in 1.16, you've been exposed to some form of unit testing framework. These exist for every language. I should hedge just a little bit. Probably every language, except the really obscure ones maybe. But any major language has a unit testing framework, probably multiple of them. So find the one for your language that you're using, that whatever you're testing. Find the unit testing library. I'd recommend just going with the most popular one and start writing some unit tests using that library. There's lots of support for this. They link up to your IDs and everything. I won't spend too much time on the specifics, but find the one for your ID, for your language that's going to work well with everything. With Eclipse, I believe Matt was using for this, either Eclipse or IntelliJ, and Java, it was just right-click, run as JUnit tests, and it runs your tests if you have them formatted in the proper way. Green means good, red means bad. We call it green barring. Once all your tests pass, you get the green bar, and life is good. You feel great when you see that green bar. You see a red bar, you're miserable, and you know you got more work to do. Maybe not miserable, but you know you got more work to do. So and you'll have a unit test. This is standard practice. I recommend you follow this. You'll have a unit test suite for each class that you create. In 1.16, I go a step further and do one for every method, but that's mostly for my grading logistics, the way that I have all the graders set up. You can write one for each class and name it whatever that class name is, and then test. So you have a nice naming convention. You can find all your unit tests very easily by just looking at the names of the files and the names of the classes. Your test suite is a class with that name, and then test all of the functionality of that class. You have multiple tests within a single test class, but make sure you're testing, confining what you're testing. Like, for example, don't write one test class that tests your entire project. Narrow it down a bit. JUnit specific, but we have the annotation, the @test annotation on JUnit test. That tells JUnit, the library, that, hey, this is a unit test, and then your IDE will treat that as a unit test. I know why he's talking about the IDE stuff. It was tripping me up. Like, why would the IDE care if it's a unit test? Because I've been working with Scala for a while. In Scala unit testing, you just run it as a regular. It's just regular code. But JUnit is quite a bit different. You have to link the library in certain ways, and it uses the annotations, just the way the specific library works. So a few annotations. Every testing, again, I'll hedge a little bit. Any unit testing framework should have at least these pieces of functionality. Some way of marking code that's run before every single test, and marking some code that's run after every single test, and then a way of marking each test itself. So when each test executes, or when you execute a test suite, your unit testing framework is going to iterate over each test. It's going to run the before code, it's going to run the tests, and it's going to run the after code. Then it's going to move on to clean all that up. Then it's going to look for the next test. It's going to run the before code, the tests, and the after code. It's going to loop through all of your tests, running that before and after, both before and after, respectively, the test. So if you have some code, you have some objects that you have to create, you have to maybe read a config file or something, and that's going to have to happen for every single test to set it up. You slap that in your before code, and then your after code, if you got to close some files or whatever you have to clean up in your after, you put that after, and then your tests can focus on what they're testing without worrying about the logistics of spinning things up, creating objects, reading files, and doing all this other stuff, all that setup. Throw that in the before, have that done for every single test. Just program everything in Ada. You can use any language you want. So every testing framework should, that's where I'm hedging my bets, just in case you're like, this one didn't have a certain null. Every testing framework should have at least these kinds of functionality. Some assert equals methods, which takes two values of the same type and checks whether or not they're equal. Something that's going to check, actually I don't know if Scala Test has this one now that I say that. Some way that's going to check floating point values with some tolerance. It probably does. Maybe I should look at that. But I even if it does, I won't use it in 1.16 because I want students to be aware of floating point truncation. But are these two floating point values within this tolerance of each other? Is this Boolean expression true? Is this Boolean expression false? Does this result to null? Is this not null? And then fail. Why does that exist? Just flat out fail? I guess. Why wouldn't I just do assert true though? Anyway, you need at least one. The fundamental point here is every test that you have needs to have at least one assert statement in it. If you don't have any assert statements, you're not testing anything. The way assert statements work is you're going to have these sprinkled throughout your tests, and if any one of these asserts are false, if you're saying assert equals these two values are the same, and those two values are not the same, your test fails and you get the red bar. If all of your assert statements in the entire test pass, you get the green bar and your test passes. But all it takes is one of these to fail, and the whole test suite fails. Those of you who took 331 are familiar with this concept. You're always looking at worst case. If the worst case failed, you had some input where one of these asserts was false, red bar, the whole thing is false. Your code is not correct if there was some input. There exists some input that failed one of the asserts. that where the assert didn't check out. This is more Java specific stuff. I should have deleted this slide. Why'd I keep it? Oh, because to emphasize this, your tests, you're just writing code, regular code in the language of that framework. So if you're using JUnit for Java, you're just writing Java code for these tests. So you have all of your programming prowess, all of your abilities available to you as you're writing these unit tests. If you want to put an assert inside of a loop, and you want to loop over a bunch of values or a bunch of anything, and trigger that assert for every instance of the loop, if you want to nest loops, if you want to have conditionals, if you want to have separate methods, helper methods in your tests. One thing I like to do when I'm writing graders for 116 is have a helper method that's going to do multiple asserts for me, and then call that helper method for multiple inputs. To have lots and lots of flexibility, anything you can code. Your unit tests can look like a whole program. In fact, some teams say that their unit testing code has just as many, if not more, lines of code than their actual program itself. They have all this huge testing library, test suites built up to be able to check all of their code. You can do lots of stuff here. Whatever you can code, you can write for a test. The only difference is you get to also use these methods to check things along the way. Computers suck at math. Hopefully you're all familiar with this, but I'll do a quick reminder. This should be 1. It's 0. That's no good. There is truncation in doubles. Any floating point value, which includes floats or doubles, double precision floats. So when we compare these in our unit tests, make sure you have some tolerance that's allowed to be able to compensate for truncation errors. You won't necessarily have exact values. If you said assert equals these two floats or these two doubles, they might not be equal, even if they should be equal, because you could be subject to truncation errors, have very small differences in these values that are enough to say that they're not equal each other. So we always allow some tolerance when comparing floating point values, which is whatever makes sense for your specific case. Dr. Hertz likes to use 0.001. I usually add a few more zeros in here, just so I'm, in most cases anyway, just so I'm only tolerating truncation errors and making sure that I'm not interfering with actual errors in the code. So if your tolerance is too high, maybe here assert equals 10.0.2 with a tolerance of 10, that's a bit too much unless your specific application calls for that, and you want to allow that much tolerance. But this will be true, this will pass, even though that number is very different because you have such a high tolerance. And this one will fail. They're much closer, but you have a tighter tolerance. You're not allowing much difference in there. But some very small value, we usually call it epsilon, at least in mathematics, and allow only that much variance in those floating point values. But if you don't have any tolerance, any truncation error is going to fail your tests. You're going to fail without broken code, which is never anything we want our tests to do. We don't want our tests to fail working code. That's not something we want to do. So here's our kind of outline of writing tests. Create all your setup, your before stuff, or if it's a smaller test, just put it in the test itself. Create your objects, prep your inputs and everything. Call the method being tested. Verify the return value is correct, and check if you have side effects that you need to test. Make sure you're checking those side effects. And you can also verify that other things did not change. Make sure you're not changing any state that shouldn't have changed. And you can also check, I read this before and I wasn't quite sure what he's getting at here. Assert array and object arguments are also correct. If you want to decipher that and check what that is too. I'm not quite positive. But check everything. So let's look at some example. This code, I'll let you stare at this for a little bit. We're kind of crunched for time here. I'm a little past halfway. This code does not behave how it should. I'll give you a little bit of time if somebody wants to try to find the bug here. This is a bug that really bit me one time, so I was able to spot it when I was reviewing the slide. I'm assuming that it also bit Dr. Hertz at some point, which is why he would make an example like this. I bet he got bit by this too. It's a tough one. It tough as in it took a few years off of my life, I feel like. Error in sum. I mean, you got to be more specific than that at least. Can't do A plus B. So you can do it. This code, there's no compilation errors. But it will fail proper unit testing. Yeah. Regression testing is important too. Once that library updates and it breaks your code, oh, how frustrating. Because the variables are private. Looks like stick figures got it. Please tell bug I don't want to lose my lifespan. Yeah, hopefully this one, if you do come across this bug, hopefully it doesn't destroy your. At least, yeah, I think it took like an hour of my day, but hopefully it doesn't. But it was so frustrating that it sucked. Hopefully it doesn't get you. Yeah, exactly. Chat's got it. Shariella. Yep. JKaz, yeah, we got it. So the problem is right here. Some string plus A plus B. A and B are ints. So what we want to say is sum is A plus B. But since we have a string, this plus is going to be concatenation. That A is going to be converted to a string. We're going to have sum is whatever the value of A is. And then plus, since this is a string, this plus is also going to be string concatenation. And the B is going to be converted to a string and then concatenated. So if we have 3 plus 2 here, A and B are 3 and 2 respectively, we're going to get the sum is 32 because they're going to be concatenated as strings and not as ints. This is a perfect case where unit tests can spot that in no time. You're just going to get the wrong answer. And when we were getting the wrong answer on that project, we're like, we know what's wrong, but why would you ever return that value? That doesn't make sense. They're not. You add them together. We just didn't know why we were failing that test. So a proper test is going to find bugs like this that aren't necessarily obvious. They're not going to jump out at you as tests because this looks right. Our minds look at this as arithmetic addition and then a string concatenation over here. But that's just not how that's resolved. Yeah, Google's going to hire you now. Chat, you got that one? Tell Google, and they'll be happy. They'll be impressed. So we're going to have a test, and we have some good testing here. We're going to create new instances of this class that we saw in the previous slide. We're going to call the multiply method and make sure that we get the right result. This multiply and the add, they're returning strings that were concatenated there. So we expect the product to be 0 on both of these. This is a good test. It's testing the edge case of a 0, making sure that multiplying by 0 is going to give us what we expect. Run as Java specific, run as JUnit tests, green bar. Woo-hoo. If we use assert true, this is specific to JUnit, so I won't spend too much time on here. The Scala test framework will let us give a string as a second argument here. That will be the hint text if it fails. But in JUnit, assert true is only going to tell you whether the test failed or passed with no extra information. So if we have multiply of -2 and 1, say it's 2, this test fails, and it just says this fails. If we use assert equals in this library, product is 2, it's actually -2, then it's going to give us more information. It's going to say what it was supposed to be, and give us just a little more detail in our output to give us a better idea of what actually went wrong. Unless you're using a framework that allows hint text. I'll add to that one. Or a framework that, it's like Scala test actually digs, it really looks at your code a bit and gives you as much information as it can figure out. So if you have, it depends on your framework exactly. But in JUnit, only use those for booleans. So this is a bad test. This one's a little more obvious. What's wrong with this test? This test passes, by the way. And we have parentheses around our arithmetic to make sure that we're not interpreting this as copy this string one time. But there's something horribly wrong with this. I'll admit I didn't even see it. I didn't see it at first. Hopefully you all do. But this is a horrible test. Passes, green bars. It's great in that respect. But now is as good a time as any to mention one of the most important things about testing. One thing I always like to do, a habit that I formed. It's not testing anything. There's nothing happening here. X by 1 is never used in the assert. We're just testing if this string equals this string. Of course it does, because we're just not testing anything. Never called our method. Does green bar, test passes, then call my method. But always watch your tests fail. Especially if you're using TDD and all of your methods are just stubbed out and not doing anything, all of your tests should fail. Unless they're trivial, maybe you're stubbed it out with return 0 and the output was just supposed to be 0. But you should watch all of your tests fail. So if the output is supposed to be 0 and you stubbed it out with 0, change that to -1 and make sure your test fails. Just make sure you don't have anything silly like this. Yeah, always watch your tests fail. You should always see your tests fail. If you don't watch your tests fail, you can't be sure that they're actually testing something. It's just based on your eyes, you looking at the code. And if you're just looking at the code to verify that your tests are right, if you're capable of that, why write tests at all? Like, why are you writing tests? If you can just look at your code and know it's right. The whole point of writing tests is to automate the testing process. Watch your tests fail, break your code and make sure it fails, the tests fail, to make sure that you are actually automating something, to make sure that you're actually automating the testing and not just relying on you manually looking over your code. So we never called the method there. Didn't test anything. Here's another bad one. 1 minute left, so I'll just rip through these. We called it now. We did call our method. No assert. We don't have any asserts here. What the hell are we testing? Green bars, because you will green bar as long as none of the asserts fail. If you don't have any asserts, you're always going to green bar. Perfect test. It's never going to fail. You're always going to feel good when you run your tests. You're going to feel really bad once you deploy this code and release it to your clients and it just doesn't work. Or you take it to a meeting to demo and it just completely falls apart. So you got to have at least one assert. If you don't, you're not testing anything. Again, if you make sure you watch your tests fail, you won't make this mistake. You can't make this mistake. This can creep up on you sometimes. If you have a loop and you have your asserts inside a loop, but the loop never actually executes. So if you're looping over, for example, if you're testing an empty list as an input, and your loop is checking to make sure every element of that list asserts in some way, make sure it's correct. And your input's empty list, that test is going to pass because you never hit any of the asserts. So it can sneak up on you if you have some conditional and that conditional is always false and your only asserts are inside that conditional. It's another case where this can creep up on you. Make sure every test always executes an assert at least once. I could have deleted this one, right? Oh, I left it in for this, just to remind myself to always say, make sure you see your test fail. Your test should fail because you haven't written any code yet. If your tests are passing on stubbed out code, what are you testing? You might have specific test cases that pass just by coincidence, but your overall test, you should always red bar with no code written, or else you're not testing anything. Like, what are you doing with your testing at that point? And always, when writing unit tests, I always like to compute everything out by hand. Sometimes if they're complicated, I'll actually open Excel for this, just my habit that I've formed. I'll open Excel to do all the math and generate the input-output behavior. And hard code, there's one place where we should hard code. You can store it in a variable if you want to not have it have magic numbers and stuff. But hard code the outputs that you expect. Don't rely on your coding ability to write your test cases. So if you say sum is, and you make this concatenation error in your unit test, you probably made that same mistake in your method itself, and you're not testing anything. You're just proving that you can make the same mistake in two different spots. And this is a common mistake, far too common, I think, is where people are using their actual implementation code to write their test and to generate their test cases. If your implementation code that the test is supposed to test is being used to generate the test, you just have this cyclical dependency and your tests are going to pass because you're just going to make the same mistakes. You're using the same buggy code both to generate your test and to test and the code that's being tested. So don't do that. Always hard code this. Make sure you put exactly what you expect. Don't perform logic inside your tests. Just call the method that does the logic, and then your test just checks, did that return exactly what I expect it to return? And if you're not hard coding the expected outputs, I would argue that I would first say why, and if in your answer I would suspect that you either one or just don't feel like doing it, which in that case just do it. But two, the more dangerous one is that you don't actually know how to compute that. So if you're using that code again, your implementation code in your testing code to generate the outputs, you might not actually know what's supposed to happen. And that's another case where TDD can come into play. If you're writing your test first, you have to know what's supposed to happen in that method, so you can actually test the implementation after you have that implementation there. Oh my goodness, we're 4 minutes over already. It's only 2 slides. So then the question becomes, how much testing is enough testing? This is one of the big questions in testing. How much is enough? There's some progression of this. Either run each statement at least once. That's good. Make sure every branch runs at least once, or make sure every possible branch combination runs at least once. So visually, if I have code with a conditional, if I want to make sure all statements are hit, I could take this path through the code, and then I never have, if this conditional is false and this conditional is false, I never take these arrows. I never check that path through the code. So if I want to check all branches, I'll make sure that those arrows are all covered. If I want to check all paths, I make sure all combinations, this path, this path, this path, make sure everything's covered. I missed one in there, but make sure all the paths are covered. So how much testing is enough? Ultimately, it's up to you and your project managers, because it's easy to get overboard with testing. In testing, you're never proving that there are no bugs. You're just proving the existence of bugs. Your test can tell if there is a particular bug that you've written a test for. Your unit testing is never proving that there are no bugs. We can never write enough tests for that. That's where more 331 and mathematical content comes into play, where we're actually proving that our algorithms are correct. That's where that comes into play. Unit testing is not doing that. Unit testing is just giving us more confidence that there are not the bugs that we're specifically testing for. But it's never going to get rid of all bugs. There's plenty of software out there with lots of unit testing that still has bugs in it.